Welcome to Signal Science System subject classes. Now we are in the fifth chapter, that is continuous time Fourier transform. So this is the sixth video in this chapter. So previously we finished concept regarding the continuous time Fourier transform, and we studied properties of the continuous time Fourier transform also. We have done some problem also. Now here we are going to discuss some basic problems which are given in the open and textbook. So in this basic problems, calculate Fourier transform of these are the e power 2 t minus 1 u of t minus 1. So this is signal. The first one is so e power minus 2 t minus 1 into u of t minus 1. So we have to find the Fourier transform. So we know that. So this is similar to the e power minus at u of t. E power minus at into e of t, it Fourier transform that equal 1 by a plus j omega. But so there is a t minus 1 in place of the t. So this is nothing but here see t minus 1 it is in the place of the t in exponential and in unit step. So x for the x of t, if it is Fourier transform x of j omega, then the time shifting x of t minus t naught x of j omega e power minus j omega into t naught. So this is a case. So directly here I'm writing this. So the Fourier transform. So Fourier transform of e power minus 2 into t minus 1 into u of t minus 1. So that equal to, first write down x of j omega. So it's x of j omega that equal to 1 by. So what is the a here? A equal to 2. A equal to 2 plus j omega into e power. So this is t minus 1 delayed. So for delayed, so it must be minus j omega into t naught. Here t naught equal to 1. So leave it. So this is the Fourier transform. The next question. So it is also same. The Fourier transform of Fourier transform. Find the Fourier transform of the e power minus 2 mod t minus 1. Already here also we know the formula, that formula. So e power minus a mod t. But you don't write unit step multiplication in this. So by default it represented e power minus at into u of t plus e power a into t into u of minus t. So that equal to 2a by a square plus omega square. So this is the, so directly, so here t minus 1 in place of the t. Then you should apply time shifting property. So that equal to, so first, what is the A here? The A equal to 2. So 2 into 2, A equal to 2 by A square. So 4 plus omega square into e power. So delayed, for delayed minus j omega into t naught. T naught equal to 1. So leave it. So this is the second. So next problem. C. Fourier transform of, so del of t plus 1 and plus del of t minus 1. So we know that Fourier transform of the impulse is nothing but 1. Impulse function. So these are the basic signal. You should remember all Fourier transform these basic signals, e power minus a u of t and e power minus a mod t del of t. In revision, we will do that. We have to write in one table all formulas. In the revision, I will explain. So del of t, it Fourier transform equal to 1. So here there is a t plus 1 in place of the t, then it is nothing but advanced shifting. So directly here writing first. So del of t Fourier transform equal to 1. So for advanced, the exponential must be multiplied, that equal to e power plus j. For plus advanced plus j, for delay minus j. So j into omega into t naught. So t naught, that equal to 1. Next, place del of t Fourier transform equal to 1 e power delayed. So minus j into omega into t naught equal to 1. This is the case. So that equal to, this is look like e power j theta plus e power minus j theta. That you know that it is a formula cos, but there is no 2, then directly you can write 2 into cos omega. So this is the case. Then next problem. d by dt u of minus 2 minus t plus u of t minus 2. So here I am assuming this is y of t. I am assuming y of t. So this is x1 of t. So this one is x2 of t. Then we have to find the Fourier transform of d by dt of y of t. So this is a property. We know that the property is differentiation. So that equal to j omega into y of j omega. Then first of all, you should find the y of j omega. Y of j omega is nothing but Fourier transform of this one. So here, so first x1 of j omega is nothing but, so this is u of t. First you should write u of t. U of t Fourier transform equal to 1 by j omega and delayed. So e power minus j into omega into 2. So for that here I am writing 2 omega. So this is the x1 of j omega. Next x2, see here I am writing like this, x2 of t, here I am writing like u of minus t minus 2. So for that, so this is shifting and time reversal. First of all, here directly here I am writing x2 of j omega that equal to 1 by j into omega into next, shifting property e power minus j into 2 omega. Then apply the time reversal. What is the time reversal property? For example, x of t, it's so if it is Fourier transform, x of j omega, then x of minus t, it Fourier transform, just replace the omega by the minus omega. That is the only difference. So for this case, see, this is the formula for the u of t minus 2. So still we didn't apply the time reversal. Time reversal. For the time reversal for minus t, so the omega must be replaced by the minus omega. So here we will get the minus j omega. Here it will be plus. So this is the case. So add these two, then you will get the y of j omega. So y of j omega that equal to what is the x2? Yeah, this is so minus 1 by j omega e power j into 2 omega. Next one x1 of j omega plus 1 by j omega into e power j into 2 omega. So here minus 1 by j omega is a common, e power j2 omega minus e power minus j2 omega. This is the formula to the e power j theta minus e power minus j theta that equal to by 2j. Here must, so 2j already here we have j, then multiply 2 and divide by 2. So minus 2 sine 2 omega by here omega. So it is only y of j omega. So this is y of j omega. See, this is only y of j omega value only. This is not answer. So what is the answer actually? The Fourier transform d by dt of y of t is j omega. So j omega must be multiplied. So the Fourier transform of so d by dt of y of t that equal to so j omega into minus 2 omega omega. So omega gets cancelled. So that equal Fourier transform of d by dt of y of t. So omega gets cancelled. So minus 2j sine 2 omega. So this is the answer. See, you will get doubt here. U of how we will get the Fourier transform for the u of minus t minus 2. See, first of all, here I am writing u of minus t Fourier transform equal to that equal to minus 1 by j omega. Is it? Now, so here I am writing minus of t plus 2. t plus 2. So this is now this minus minus and t. So there is a t plus 2 in place of the t. Is it? So time shifting. So that equal to minus 1 by j omega into e power. So t plus t, it is in the place of the t. J into 2 omega. In this way also we can do that. Okay, next problem. See, here determine inverse Fourier transform, not Fourier transform. Inverse signal, it is in the frequency domain. Then we have to do the find the inverse Fourier transform. So first of all, here I'm writing. I would like to write this signal in the x1 j omega that equal to 2 pi del of omega plus pi into del of omega minus 4 pi plus pi into del of omega plus 4 pi. So here we know that del of t, so Fourier transform 1 and 1 Fourier transform that equal to 2 pi del of omega and 2 pi del of omega minus omega naught. So frequency shifting property. For that, the 1 must be multiplied by the exponential that equal to here this minus. So here place will become here. So e power plus j omega naught into t for the 2 pi into del of omega plus omega naught. For that case, 1 must be multiplied by the exponential that go omega naught into t. So inverse Fourier transform. So inverse Fourier apply inverse Fourier transform on both sides. Then it becomes the time domain signal x1 of t that equal to directly we have the formula. So that equal to 1 place. So there is no 2 pi. So there is no 2. So multiply and divide for that. Here I'm trying 2. So 2 pi into, so this is frequency shifting. So that 1 must be, so e power, so minus, then here we'll get j into, what is the omega naught? 4 pi. This is the omega naught. So 4 pi into t. Similarly, here also same, and there is no 2. So multiply and divide. So for the place, here we will get minus j 4 pi into t. So this is the formula for the cos function. Is cos j theta plus cos minus j theta by 2. Then directly here I'm writing x1 of t that equal to 1 plus cos of 4 pi t. So this is the answer. Then next one, see this is, I would like to draw the signal in the frequency domain. So this is a signal in the frequency domain. So this is x of j omega, it magnitude minus 2 from the 0 to 2 and minus to 2 to 0 So it's my, so this is plus. Mm, So this one is minus 2. So this is the case. Here, I would like to solve this problem by the two methods. In the first method, I have to use the formula, inverse Fourier transform formula that you know very well. That is x of t. So x of t equal to, so integral of, so here we have 1 by 2 pi. So minus infinite to the plus infinite. So x of j omega into e power, so j omega t into d omega. So this is the case. So this is x of j omega. It is having the magnitude from minus to 2 to then. So 1 by 2 pi. So minus 2 to 2. So it is better to split. Why? Because in between it having two different values. So minus 2 to 0, its value equal to minus 2. E power j omega t into d omega plus, so 1 by 2 pi, already here I have written. So 0 to 2, so its magnitude equal to 2 into e power j omega t into d omega. Now do the, so 2 gets cancelled, so minus 1 by pi. So e power j omega integration with respect to omega, then in denominator we'll get j into t. So minus 2 to 0. Here also, so 1 by pi. So this 1 by 2 pi, 2 gets cancelled, 1 by pi. So e power j omega t by j into t. So 0 to 2. So minus 1 by pi. So e power j, so it goes to 1, and minus e power j. So these are the limits for the omega. So they're equal to 2t. So this is the case. So plus 1 by pi. So e power j 2t minus 1. So there is a jt. Take 1 by pi common. 1 by pi jt. So that equal to e power j2t minus 1, and here plus e power minus j2t. Why? Because here there is a minus. So minus 1. So e power j theta plus e power minus j theta, that equal to cos function. Then here I'm writing like this. Pi jt, these are, it becomes a 2 cos 2t, and minus 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 2. Now I'm converting from the cos 2 theta to the sine, then 2 into 1 minus 2 sine square t So minus 2. So this minus 2 and this 2 gets cancelled. Then here 1 by pi j t equal to 2 minus 4 sin square t minus 2. So it gets cancelled. Then finally we'll get plus j. See, so 2 2 gets cancelled. Here minus 4 sin square theta will get. Then here I'm writing j 1 by j equal to minus j. So minus minus plus minus into minus plus. So directly here I'm writing j into 4 sin square t by pi t. So this is a method from the inverse Fourier transform formula. We can also solve this one with the help of the properties. For example, we know that mm, see, so this is the one rectangular pulse in frequency domain. We know that it's, for example, this is a magnitude equal to 2. So the 2 into sine of WT by pi t. But here I'm assuming this is x1, this is x2. So here this comparing to this y of j omega, this x1 is shifted to same. So if we double equal to 1, if double equal to 1, so the width equal to, here also the width equal to, so this is look like shifted to right side by 1 unit. So right side shifted. So in frequency shifting, we know that in frequency shifting, in delayed, exponential must be multiplied, is it? So directly here I'm writing, uh, so these are x1 and x2. So the x of j omega, equal to, first of all, x1. So this is shifted. So this is, so 2 into sine of the double equal to 1 t by pi t. So this is frequency shifting. Frequency shifting, it is must to be multiplied by the e power j into the omega. This is omega naught. Omega naught. This is shifted by the 1 unit. So omega naught equal to 1 into t. This is about x1 of j omega. Next x2 of x2. So it is having the minus 2 magnitude. So minus 2 sine of, so sine of same pi t. So this left side shifted by 1 unit. So e power minus j into t. So x of j omega equal to, so 2 sin t by pi t is a common. So 2 sin t by pi t is a common. Then here jt and minus e power jt. So this is equal to the 2 sin t. So 2 sin t. Sorry, here must be, should have 2j and 2j. So 2 sin t into this is so sin t into 2j pi t. In final step, we are getting 4j sin square t pi t. So this is, so this is the method 1. So this is method 2. This is property based and this is formula based. Next, here given the relations y of t equal to x of t convolution of this h of t, and g of t is given x of 3t convolution h of 3t. Then, so x of j omega given h of j omega, these are the Fourier transform of the x of t and h of t, and g of t is given in terms of the y of t, then find the a and b. So this is the case. So here I would like to write two properties. One is scaling property and convolution property. In convolution property, you know very well. So this x of t convolution, its Fourier transform. So its Fourier transform equal to, so multiplication in frequency domains. Simple thing. X of j omega and y of j omega. And scaling property from the x of at, the scaling property equal 1 by mod a into x of j omega by a. So this is the case. These are the Fourier transform. So this is very, very important problem. Step by step, we will see that. First, here I'm writing formula. First, y of t equal to x of t convolution h of t. Now here I am applying the Fourier transform. Then y of j omega, that equal to so Fourier transform of this convolution x of j omega and h of j omega. Is it? Now taking the second relation, that equal to g of t equal to x of 3t convolution h of 3t. So here for after applying Fourier transform, this is, it becomes the g of j omega. Here Fourier transform convolution, you know that multiplication of this one, and also it is inbuilt each signal having the some scaling. So scaling also we can apply. So individually first you should apply. So 1 by 3. So x of j omega by 3 Next here, the multiplication for convolution, here we will get the multiplication. Write down the scaling property for this h of 3D that equal to 1 by 3 into h of j omega by 3. Now, for the simplification, 1 by 3 into 1 by 3 into x of j omega by 3. So, h of j omega by 3. So, this is the function of the frequency. So, here in small modification, so here I am replacing the omega by the 3 omega. Then every omega must be replaced by 3 omega. Just why? Because this is the function of the omega. No? So g of j into 3 omega. 3 omega. So omega replaced by 3 omega, that equal to 1 by 3 into 1 by 3 x of j omega. So substitute the omega 3 omega. The 3 gets cancelled. So here also h of j omega. So x of j omega and h of j omega, that equal to y of j omega. We know that. So 1 by 3 into 1 by 3. So this formula already here we have written that y of j omega j into 3 omega. Now here I want to replace the omega by the omega by 3. Omega by 3. Then j into omega by 3, 3 gets cancelled. Then we'll get to omega. So 1 by 3, 1 by 3. Here the omega must be replaced by the omega by 3. Now, so now apply inverse Fourier transform. Inverse Fourier transform equal to, so g of t, so g of t equal to, so 1 by 3 here. This is it look like a scaling property, is it? So 1 by 3. Then y of that equal to 3 into t. So this is the case. So compare this equation. Where is y g of t equal to, so a equal to 1 by 3, b equal to 3. So this is the case. Next problem. Find the Fourier transform of the t into e power minus mod t. Already we know the formula, that is formula. So e power minus a into mod t, the formula equal to 2a by a square plus omega square. So here a equal to 1. So what is the t? So now this function is multiplied t. Then what we have to do that? So whenever any function is multiplied by t, you should remember this is the related to the property of the differentiation in the time domain. Here I'm writing. For example, this x of t, so this it's Fourier transform equal to x of j omega, then d by d omega x of j omega multiplied by j, so it is equal to the t into x of t. So this is the case. Now, so this x of t, so for this is a function x of t, so this is t multiplied. Then it's Fourier transform equal to, then the Fourier transform of, so t into e power minus mod t, so that equal to then j into d by d omega So what is the x of j omega? So this is the x of j omega. So x of j omega here a equal to, so this is compare this one. Then 2 into a equal to 1 by 1 plus omega square. So this is the differentiation. Now we should do the differentiation. So j, so this is u by v formula. That u by v formula. So u by v square. So what is the v? 1 plus omega square whole square. Then v, you write down the v equal to 1 plus omega square into u dash. So 2 dash equal to 0. So minus v dash. So v dash equal to 2 and u into v dash. So 2 into v dash, that equal to 2 omega. So that equal to what we are getting? So this is minus 4j omega by 1 plus omega square to the power of 2. So this is the answer. Then next question, use the result from the part A along with the duality property to determine the Fourier transform. So find the this is. So duality property, it tells, say for example, t into e power minus mod t, Fourier transform equal to. So it Fourier transform equal to. So here we got minus 4j omega by 1 plus omega square. So this is the second one. This is A, this is B problem. This is the part A. I have written this equation based on the part A. This Fourier transform already here we derived. 1 plus omega square square. In duality, in a simple case, so minus 4 j omega duality, it's so 1 place, sorry, in duality, omega must be replaced by t, so plus, so t square, so that equal to, so 2 pi into this one, omega into e power minus of omega. So this is the duality. So what is the Fourier transform? 4t by, see, 4t 1 plus t square whole square. Only j, there is no minus j. Now we can send to, this is the constant, then we can able to send to the right side. So 4t by 1 plus t square whole square. So that equal to, so minus j, so here minus j, then so 2 pi by, so minus j omega e power minus omega. So it becomes, so Fourier transform of 4t 1 plus t square square, so that equal to 2j pi 2j pi omega e power minus mod omega. So this is the answer. So this is about continuous time Fourier transform, some problems. Next class we will focus on the previous year questions asked in the Indian Engineering Service examination. Okay, thank you.